All right, in this example, we're told that the cosine of theta is equal to -3/5, and we're asked to find the exact values of these other trig functions: sine, tangent, cosecant, secant, cotangent, on this interval from pi to 3 pi over 2. All right, so first thing I want to do, I'm just going to draw my unit circle. All right, so I'm just going to draw a unit circle with a coordinate axis in it. And the interval here that we're talking about, theta between pi and 3 pi over 2, is down here in the third quadrant, right? This is the third quadrant, where both x and y are negative. Okay, so it can help, first of all, to kind of sketch in what that angle must look like, because the cosine is a -3/5, right? So it has to come over, the x value has to come over by -3/5. So a little more than half, right? So let's say it's there, and then it drops down here to the x-axis, or sorry, to the circle itself, to the unit circle. All right. So this, because this is the cosine, the x value is the cosine, then this leg is a -3/5. Okay. And then the angle has to be this. It has to be the angle at this position on the unit circle. Okay, so it can sometimes help to see what the triangle looks like. And I know that the radius of the unit circle is 1. And from the Pythagorean theorem, I can figure out now this other side, which is going to be the sine, which is this first thing that we're asked for. Okay, so I can just find that, okay, well, it's going to be the square root of 1 minus this other side squared. So it's -3/5 squared. Now make sure you're squaring -3/5, which means -3/5 times -3/5. So -3/5 squared becomes a positive 9/25, right? And so let me just rewrite this. So it becomes, I'm going to rewrite 1 as 25 over 25. Because I know I have to subtract something with 25 in the denominator, because 5 squared is 25, and then this is going to be positive. It's minus this positive, so it's 9/25. Okay, so all of that under the square root. And now I know that 25 minus 9 is 16, and so I still have this 25, right? Because I have a common denominator here, I can combine those two fractions. And so square root of that whole thing, which is square root of 16 is 4, square root of 25 is 5. So it ends up being 4/5. Now be careful though, because notice that we're in the third quadrant. So the sine value has to be negative. So it's actually going to be the negative. All these should probably be negatives, right? Because I know that it's going to be negative because it's in the third quadrant here. So my sine value is -4/5. All right. So now from that, I can also find the rest of these trig functions, right? Because I know that the tangent is sine over cosine, right? So that's -4/5 over a -3/5. Right? I can multiply top and bottom by 5, and I know that these negatives will cancel each other out, so I end up with 4/3. So the tangent is 4/3. The cosecant is 1 over sine, so it's just going to be the reciprocal of the sine value, so it's going to be -5/4. The secant is going to be 1 over cosine. I didn't need to do anything for that. I just need to take the reciprocal of cosine, so it's going to be -5/3. And the cotangent is essentially just 1 over the tangent. So the reciprocal of tangent, since tangent is 4/3, the cotangent is going to be 3/4. Okay, so that's all of those trig functions. We figured them all out. Now there's actually a different way we could do this. We could recognize that sine squared of theta plus cosine squared of theta is equal to 1. And that's another way that we could come up with our sine value. Because sine squared of theta has got to be 1 minus cosine squared of theta. And so sine squared of theta has to be 1 minus, 1 minus the square of negative 3/5, which is 9/25. Okay, that has to be sine squared. But you can see we're going to get the same thing that we did this way. Okay, so you can do it either way. You can draw the unit circle, or you can just use the Pythagorean identities to figure out the sine, and then once you have sine and cosine, you can really figure out everything else. So I will meet you in the next. Well, actually, there is no next video, isn't it? This is the last example. So let me just briefly tell you I don't have any examples to go with this, and I think we've talked about this before, that the sine and cosine are basically horizontal shifts of each other. It's just shifted by 90 degrees. Okay, so you can see here that the sine is the cosine function if we were to shift that cosine function to the right by 90 degrees, right? The cosine is the sine function essentially shifted to the left by 90 degrees, right? Pi over 2. So there's these relationships between sine and cosine. So we can always turn a sine into a cosine by shifting it one way or another. All right. Well, that's all I have for this lecture, and I will meet you in class.